So, good morning. Today we're going over 2.2, graphing piecewise defined functions. I'm just going to call them piecewise functions just for purpose. Now, in order to sketch or graph a piecewise function, you have two different equations. So you can think about it as f of x is equal to x squared, and then f of x is equal to 2x plus 1. Now, because it's piecewise, you're going to have one part of the graph being 1 and then the other part of the graph being the other. Now, how do you know where that cutoff area is? It's always going to be that number, obviously depending on which one. For the x squared, it includes the 1, and for the 2x plus 1, it doesn't. How do you figure that out? If you have a less than or equal to, greater than or equal to, that is a closed graph, which you usually do with a line or with a closed circle. So that's why it means included. If you have it less than or greater than by itself, it means it's open. So it means it's not included. So you would do it with a dashed line and then an open circle. Again, you would mark that number at that 1, but it'd be either closed or open based on the type of inequality that you have. So how do we figure out the points? If you guys remember how to graph with slope-intercept form, you can go ahead and just do that. I'm going to go ahead and take it one step at a time, starting with just a table. So for the, let's say f of x is equal to x squared. If x is less than or equal to 1, I'm going to make myself an xy chart. Now I am going to choose, since it's less than or equal to -1, I'm going to start with 1. When I plug 1 in, it's going to be 1 squared. So that gives me 1. So we have the point 1, 1. Since I'm doing less than, I'm going to go ahead and do 0. And then 0 squared, it's going to give me 0. So we're left with 0, 0. Then we have -1. When we plug in -1 squared, that means it's positive 1. So we have -1, 1. I'm going to do a few more points, -2. So it's -2 squared is 4. So we get -2, 4. I'm just going to do one more point. -3 squared is going to give us 9. So we're left with -3, 9. I can actually go ahead and plot those points. Now, since we see it's less than or equal to at where x is equal to 1, so this imaginary line right here, that's where our graph is going to separate from the x squared to the 2x plus 1. We're doing x is included because it's less than or equal to for the x squared. So at 1, 1, that's going to be a closed circle. Then we have 0, 0, -1, 1, -2, 4, -3, 9. So we have this graph like this. Now I'm going to do the other one in blue. So we have, again, now it's a 2x plus 1 if x is greater than 1. So I'm going to choose some x and y points. Again, I'm going to start with the 1, even though it's not included, because we can draw a closed circle, and that is important. That is one of the points you have to find, which is where that x is equal to that number. So if we try x is 1, it's going to be 2 times 1 plus 1 is going to give us 3. So we have the point 1, 3. I'm going to go ahead and try 2. It's 2 times 2 plus 1. That's going to give us 5. So it's 2, 5. I'm just going to find 4 points. Then we have 3. So it's 2 times 3 plus 1. That's going to be 7. So it's 3, 7. Then I'm going to do 4. 2 times 4 plus 1. That's going to be 9. So we're left with 4, 9. So I'm going to go ahead and graph those. So we have 1, 3. Again, it's going to be this time an open circle because it's not included. But you have to find the points of that line where they break up into two graphs. Then we have 2, 5. Then we have 3, 7. And then we have 4, 9. And then I'm just going to go ahead and draw the line. On the completed notes, it looks a more straight line. This one I'm kind of eyeballing. But please bear with me, your graph should look somewhat like this. The dotted line is only for inequalities, since when we graph them, I went a little ahead. Since these are equal signs, we're just going to do a straight solid line. Now we have 3 equations in this case. The negative 4x plus 3, the a half x minus 1, and then a 3. So I'm going to go ahead and just do an FY chart of the f of x is negative 4x plus 3. Again, if x is less than negative 1. If we do xy chart, I'm just going to choose a few points. Again, 2, 3 points. You have to keep going to crazy from there. I'm going to start at negative 1, and then I'm going to pick smaller numbers. So negative 2, negative 3, negative 4. I'm probably just going to stop around negative 3, depending on how high the y gets. So we're going to do negative 4 times negative 1 plus 3. That's going to give us positive 4 plus 3 is 7. Then let's do negative 2. So negative 4 times negative 2 plus 3. Negative 4 times negative 2 is 8. 8 plus 3 is 11. It's going to be negative 2, 11. Now, because again, the inequality does not have the or equal to, it means it's an open circle, because that solution at negative 1 is not included. I doubt I'm going to have enough space to even graph any more points, but I'll just find one more, just to make sure the math is making sense. So negative 4 times negative 3 is 12, plus 3 is 19. So clearly there's not enough space for me to do this. Now we got to make sure that at negative 1, for now I'm going to highlight those numbers at negative 1. We also have one at positive 3. Now why am I highlighting where the x is equal to that? Because that is where the graphs are going to be separated. Now we're doing from when x is less than 1. So I'm going to go ahead and start at negative 1, 7. It's going to be an open circle. And then it's going to be negative 2, 11. So it's going to be kind of up there. So you can just draw the line upwards. Sorry, that last point should be 15. My bad. The reason I drew 2 red highlighted lines at the negative 1 at the 3 is because since we have 3 parts to this piecewise function, we have to find the left part, the middle part, and the right part. And it's all told to us based on these domains. So if we have the half x minus 1, that's going to be the in-between, because it's saying it's in between negative 1 and 3. So when you're finding those points, you can either find the points or do it in slope-intercept form if it makes it easier. You're only going to graph from negative 1 to 3. Now keep in mind, at the negative 1, it's going to be, the graph is messed up. This should be close right here. This one shouldn't exist. Or they could both be close and this one shouldn't overlap. If there are functions, that the closed circles are not going to overlap. So just for the time being, please, this doesn't exist, that line. So it works as a function. Let's go ahead and do the f of x is equal to a half x minus 1. Now you can do it a few different ways. Again, it's in between the negative 1 and the positive 3. If I were to do an XY chart, I'm going to have to choose numbers like negative 1, number 0 I can choose number 2, and I have to choose number 3. Now, only 2 of those numbers are going to give me whole numbers. So, which is fine. We can do it. It's going to be a half times negative 1 minus 1. That's going to give us negative 3 over 2. So we get negative 1, a negative 3 over 2, or negative 1 and a half. If we plug in 0, we're going to get -1, 0, -1. If we plug in 2, we're going to get 0, so it's going to be 2, 0. And if we plug in 3, we're going to get 1/2, which is 3, 1/2. Again, in this case, this first one's closed because of the inequality or equal to. Same for the bottom, it's closed because of the or equal to. Remember, we changed this one, so it would be a function. So you can either do that, which is fine. You're going to get the points, -1 and -1.5 is going to be right there, closed circle. Then it's going to be 0, -1. It's going to be 2, 0. And then it's going to be 3 and then 1/2. So you're going to get this line right here. Again, closed circle. Another thing you could have done, if you rather, instead of getting the points, you could have used the slope-intercept line, or slope-intercept y equals mx plus b. And if you do that, you have a slope of 1/2, and you have a y-intercept, which is b of -1, based on the given equation. So if you look at that, you plug in the -1, and then you go up 1 to the right 2, up 1 to the right 2, and then you just stop where the lines intersect, the red highlighted or the points that you have to cross. It's up to you what you prefer. I just wanted to show you both. When it comes to fractions, and if I can choose fractions that are whole numbers, I tend to try and do slope-intercept to make it easier on myself, as I don't have to deal with adding whole numbers and fractions. But you can do them and you will get the exact same answer. Now, if I were to do the third one, which is f of x is equal to 3. Now, this is if x is greater than 3. If I were to plug any point, 3, this would be 3. So it would be 3, 3. If I were to plug in 4, this is still going to be 3, 4, 3. If I were to plug 5, this is still going to be 3, 5, 3. Because there's nothing I can do to make the x change this equation. So this is open. Again, I'm just writing it in because we changed those two in order for it to be a function. So I'm going to start at 3, and then it's just open circle. And then everything else is at the 3 mark, so it doesn't matter what I draw, it's just going to be a horizontal line to the right. So a few rules on how to know when a system is a function or an equation is a function. For if you're graphing them, you can tell based on the domain, like we just fixed it, by doing the vertical line test, any of that type of stuff. Now, if you just have the equation and you're not going to graph it, these are a few things that you can do to figure it out. So a rule that assigns each element x is a set of a exactly one element of y. So remember, if you have, I'm just going to do a mapping diagram. You have exactly one x for one y. So the x cannot be repeated. That's what this means. The second one is using points. No x can be repeated with a different y. So what does this mean? If you were to have a graph and you have an x here and an x here, for a piecewise, for example, and you have a square this way and then a line this way, because these two touch in the exact same point, that is no longer a graph. No longer a graph. It's no longer a function because you have two x's on the same y. So again, you cannot repeat the x value. You can repeat the y all you want. A horizontal line like we had earlier, like this, that is a function because you do not repeat the x anywhere. So for functions, we really care just about the x when it comes to graphing. Y can be repeated forever and ever. We do not care, just x cannot be repeated. That's why when the open and closed circle matters, because if you were to have this same graph, open circle, and then closed circle, this would be considered a function, because even if I draw the vertical line, the open is not included, but the close is. So that would still be considered a function, even though they quote-unquote share an x, one x is not included and one x is included. Now, if you are not graphing, that's the part that's highlighted in yellow. So when you're using equations, y cannot be raised to an even power or in absolute value. Why does that matter? So if the y is an even power, you're going to get a graph that looks like this. Again, sharing x points. So this is just an example. You're going to get a graph that's horizontal like that, sharing 2x points, no longer a function. And if the y is the one in the absolute value, the same thing's going to happen. You're going to get a horizontal v, just like an absolute value, but sideways, which again are not going to be a function. You can have an even for the x, but not an even exponent for the y. Your x can be absolute value, but your y cannot. So you want your y to just be plain and simple by itself. You can have a cube y, and when you take the cube root, it's going to be fine because it's going to look like this, and that's still not going to be overlapping x's. So if you remember the rules, if you don't remember anything of how the graphs look, because I'm not expecting you to, the y cannot be an even power and cannot be an absolute value. And then for the other ones are all kind of graphing based rules for functions, which again you can figure out with the vertical line test, which is just you can draw a vertical line anywhere on the graph, and if they happen to touch the x value twice, that is when it's no longer a function, and as long as it fails once, it's no longer a function. So equations that define functions. Does the equation define y as a function of x? Let's figure it out. So we have this a value. I'm going to do it right here on the side. We have y minus x squared equals to 2. Now I want to make sure the y is by itself, so solve for y. So I will do that by adding the x squared on both sides. I'll get y is equal to x squared plus 2. Now, since the y is not squared, we don't have an absolute value on the y, and everything else seems good. Yes, this is a function. Now let's look at the second one. B, let's solve for y. We have x squared plus y squared is equal to 4. I'm going to go ahead and subtract the x squared, and we get y squared is equal to negative x squared plus 4. We have a square for the y, which is one of the rules we can't break, so this is not a function. Now let's look at C. We have the absolute value of x plus 3 plus 2y is equal to 0. I'm going to go ahead and subtract the absolute value of x plus 3. And we get 2y is equal to negative absolute value of x plus 3. I'll divide by 2. And we get that y is equal to the negative absolute value of x plus 3 over 2. Again, the y is plain and simple by itself. So this is a function for the third one. Now I'm going to add a slide for D and E, just for space. Now for D was 3y squared minus 2x is equal to 9. Now if you notice, we already have a square, so it's not going to be a function. But just for a rule of thumb, there's sometimes that they cancel out. This one won't. You can go ahead and solve for it. So you get 3y squared equals 2x plus 9. I'll divide everything by 3, and we get y squared is equal to 2x plus 9 over 3. And now, again, some cases the y squared does disappear, so it's always good to solve for it. But in this case, it didn't, so it's not a function. And then for E, I'll write it in and leave D up there. We have the absolute value of x plus y equals to negative 16. There's really nothing you can do to solve for this one. Starting off the bat, that you can't have an absolute value equal to a negative number. The second thing that is messed up here is that the y is included inside of the absolute value. So you can just go ahead and say not a function.